Hello and welcome to this lesson on independent events. If you want to put today's date and the title and have a read through the do now task, have a go at it in your exercise book and then pause the video when you want to mark your work. So in a small village, one bus arrives a day. The probability of rain in the village is 0.3. If it rains, the probability of a bus being late is 0.4. If it does not rain, the probability of a bus being late is 0.15. So using that information, you needed to complete the tree diagram. So the first branches then, we've got rain or not rain, and the probability of it raining in the village is 0.3. So the probability, hopefully you filled in, of it not raining is 0.7. So then we're told if it does rain, the probability of a bus being late is 0.4. So if it rains, the probability of it being late, 0.4. So then the probability of it being on time, as remember the probabilities on, so this is a branch, this is a branch, the probability on the branches need to add up to 1. So if it does not rain, the probability of a bus being late is 0.15. So subtracting this from 1 would mean that it being on time is 0.85. So there you would get the marks for completing the tree diagram. Part B, work out the number of days the bus will be late over a period of 80 days. Now remember, an expectation of how many days it will be late will be the probability of it being late multiplied by the 80. So there are 2 occasions where the bus could be late. So it could either rain and the bus be late, or it could not rain and the bus be late. Remember, when we go across a tree diagram, we want this and this to happen, so we will multiply them together. So the probability of it raining and being late would be 0.3 multiplied by 0.4, so this would give you 0.12. So the other option of being late is no rain and late, so 0.7 multiplied by 0.15 to give you 0.105. So combined then, the probability that the bus is late on any occasion, it could be this option or this option. Remember, this is the or rule, and then we combine these, we add these together. So the probability of it being late will be 0.225. So if we want to know out of how many of the days the bus will be late, we need to do 0.225 multiplied by 80 to give us an expectation that the bus is late on 18 of the days. So today we are going to look at independent events, and we're going to look a little bit more closely again at the connectors, the and the or rule that you wrote down at the end of last time. So our success criteria is bronze is to be able to draw a tree diagram for probabilities. Our silver objective is for you to know and apply the and the or rules, which we looked at last lesson too. And our gold objective is to find the probability of combined independent events. So independent events, then you might want to write this down. If the outcomes of an event A do not affect the outcomes of an event B, then events A and B are independent events. One does not affect the other. Most of the combined events you have studied so far have been independent. So this was the and rule. So if A and B are independent, then the probability of A and B happening, so this is going across a tree diagram, is the probability of A multiplied by the probability of B. The next 3 examples are going to show us how to work out problems about combined events without using tree diagrams. So the method is similar to using a tree diagram, and we're just going to use the rules and the words for and or. So let's have a look at this example here. The chance that Ashley hits a target with an arrow is 1/4. He has 2 shots at the target. What is the probability that he hits the target? So part A, we want him to hit the target both times. So I want him to hit the target and hit the target. So this means hitting the target is a probability of a quarter, and I want the probability of him hitting and hitting. So this is the and rule where we are going to multiply. So the probability that he hits both times is the probability of the first shot hits and the second shot hits. So this is a quarter multiplied by a quarter, which would give us 1/16. Now we want the probability that he hits the target just once only. So if you think about this, this means there are two ways this can happen. He could hit it with the first target but then miss with the second, or he could miss with the first shot and then hit with the second. So we first of all need to work out the probability that he hits with one and then doesn't with the other. So the probability that he hits with the first shot is a quarter, but then he's got to miss with the second shot. So I want this and this to happen, so we multiply the probabilities. Or this could happen by him not hitting and him then hitting on the second one. So this would then mean I add these two options together. So this would be 3/16. This is also 3/16, which is two lots of 3/16. So we get 6/16. So the probability is 3/8. So notice the connections between the word and or. So if I want something and something, we multiply. So this is where these come from. And then I want this option or this option, which is why I then add these two probabilities together. So at least problems, and these occur quite commonly in exams. So when you are working with combined events, you may need to find the probability of at least one of the outcomes occurring. And there are two ways you can do this. Now, if you think about it, if you want at least one of something happening, think about maybe you have 4 marbles in a bag, and you want to know the probability of at least one of them being red. So that could mean the first one is red and then the other 3 doesn't matter what colour they are. You could have 2 red and 2 different colour. You could have 3 red and 1 different colour. And then there are lots of different ways that could happen. So if you write all the possibilities out, this could take quite a long time. But if you actually think about it, alternatively, if you want at least one of them to be red, so that would mean then this is the same as 1 minus the probability that none are red. If you want at least one of them to be red, that's all of the combinations that have a red option in it. It just doesn't include the one where none of them are red. And knowing that probabilities have got to add up to 1, if we do 1 minus the probability of none of them, this gets us to the answer much quicker. So let's see this in practice. A bag contains 7 red balls and 3 black balls. So 10 balls altogether. Anton takes out a ball, notes the colour and replaces it. He does this 3 times. What is the probability that he takes out no red balls? So I want not a red and not a red and not a red. So that would mean he needs to take out a black ball and a black ball and a black ball. And we know the probability that he takes out a black ball will be 3 out of the 10, so 3/10, and I want it on the first occasion and the second occasion and the third occasion. So and means I multiply the probabilities. So 3 times 3 times 3 would give me 27. 10 times 10 times 10, or 10 cubed, gives me 1,000. It's the next one that's the tricky one. So I want at least 1 red ball. So at least 1 red is the same as 1 take away the probability that there are no reds. So the probability that there are no reds is actually what we worked out in part A. And this is what you will find with most GCSE questions, is that the part B that follows on generally tends to use something that you've worked out in part A. So watch out for this. So the probability of no red is what we worked out here, 27 1,000ths. So probability of no reds is 27 1,000th. So we do 1 minus this, which gives us 973 thousandths. Okay. A more advanced use of the and or. So we've already seen how to solve some probability problems related to independent events by using tree diagrams and the and or method. So these methods are similar, but the and or method works better in the case of three events that occur one after another, or where the number of outcomes of one event is greater than two. This is because the tree diagram would be too large and involved. So generally when there are two events, we draw a tree diagram and use that. So it's when we are looking at three or more an event occurring, when we tend to not draw the tree diagram and just use the and or rules. So let's have a look at another example. Josh picks 3 cards from a normal pack. He replaces each card and shuffles the pack before picking the next card. What is the probability that he draws? A, 3 kings. B, exactly 2 kings and 1 other card. C, no kings. And D, at least 1 king. So part A, B and C are relatively straightforward, and then we need to think about D. So for part A then, hopefully you're familiar from doing work with packs of cards earlier in the video lessons. So remember, with a normal pack of playing cards, there are 52 cards and there are 4 suits. So there are 13 cards in each suit. Remember, the suits are hearts and diamonds, which are the red cards, and spades and clubs, which are your black cards. So the probability then that we pick 3 kings will be the probability of a king and another king and another king. Now if we think about each suit, there is 1 card out of 13 which is a king. Now you could think, well actually there's 4 kings out of the 52. Yes, that's also correct. It would just cancel down to 1/13. So the probability of a king and another king and another king is 1 over 2,197. Part B, I want exactly 2 kings and 1 other card. Now I need to think really carefully about this, because exactly 2 kings and 1 other card, there's 3 different ways that this can happen. So I could have a king, and not a king, or I could have a king, not a king, and a king, or I could have had not a king, and another king. So I need to work out the probability. So it's 1/13 multiplied by 1/13 multiplied by 12/13. Now you'll probably notice is that these probabilities are all the same. The numbers are just in different order. So actually this here is just 3 lots of 1/13 times 1/13 times 12/13. Either way, you just got to be really careful when you're popping this into your calculator using the bracket keys, or you could just work this out and then multiply it by 3. So if you try this out, hopefully you come out with 36 over 2,197. Pot C then, no kings. So this is slightly easier. So I want not a king and not a king and not a king. So 12/13 cubed, or 12/13 multiplied by 12/13 multiplied by 12/13, which would give 1,728 2,197. So part D, at least 1 king. So remember, at least 1 king is 1 minus the probability of no kings. If you start to try and write down all of the combinations, you can very easily make a mistake. So use this method, try and remember it. So this would be 1, take away the probability of at least, the probability of no kings, and lo and behold, look, we've just worked this out in the previous part. So it's 1 minus the previous answer, so it's 469 2,197. So now then, pick some questions and have a go at exercise 19D. So if you pause the video and have a go at some questions, and then I've popped the answers also within the PowerPoint. It's just I've put the answers at the end this time. Okay, before I leave you then, I'm just going to have a look at question 11 with you. So Evie's mathematics teacher told her that the probability that she gets her mathematics homework correct is always the same. So in 4 homeworks, the chance of her getting at least 1 incorrect is 0.5904. What is the probability of Evie getting her mathematics homework correct on any one occasion? So if we think about this then, the probability of at least 1 correct. Now remember, at least 1 correct, we know the easier way to work this out is 1 minus the probability of non-incorrect. So this kind of turns it on its head. So at least 1 incorrect, they tell us in the question is 0.5904. So we know from this then that 1 minus the probability of non-incorrect must be 0.5904. So from this then, we can work out by subtracting 1 from 0.5904 that the probability she gets non-incorrect, so all of them correct, is 0.4096. So this means she gets all of them correct and all of them correct and all of them correct and all of them correct on the 4 occasions. So this means all correct times all correct, because I want this and this and this and this. And remember to go backwards from this will be working out the 4th root. So in your calculator, work out the 4th root of 0.4096 and the answer comes out as 0.8.